next talk is from a visiting professor from Michigan Tech University. He was graduated from our physics department for his BSc and MSc degrees before receiving his PhD from Osaka University as a Mombusho scholar. He was a fellow of the Japan Society for Promotion of Science, JSPS, before joining Michigan Tech University in 2002. He has published more than 140 articles, including book and encyclopedia chapters, review papers, peer review articles, and conference proceedings. Here to introduce us to the promises and challenges of nanotechnology, Professor Dr. Yap Yoke Khin.
Thank you. Alright, thank you for the invitation. I'm going to talk about something related to the so-called nanotechnology. And I promise you that as a physics graduate here, I promise you that you are very competitive to this emerging area, the so-called nanotechnology. I'm going to show you some examples down here. This is the contents of my talk. I will first of all quickly define what is nanotechnology. And I will take one type of materials called carbon nanotubes as the example of nanomaterials, okay, that you might focus on to work on the field of nanotechnology. And that is why we call this promises and challenges. I'm going to take some example or applications, promising applications of carbon nanotubes as an example to see how will this be promising to change every aspect of the way you live here. And also I'm going to give you some assignment because some of the challenges are there. And finally, later I will talk to you, introduce to you some of the nano research activity in this department. And also in my research program in Tech. Alright, as a physics student, I don't have to define too much about what is nano, which is 10 to the power minus 9. And you can see that, in fact, 10 hydrogen atoms in the line in the line, it will be in a length scale of about 1 nanometer. And also the width of the DNA here is about 10 nanometer. So which means nanometer regime will be something close to atomic and molecule level, right? Now this is a broad definition of what we call nanotechnology. Okay, it's sometimes we call this nanoscale science and engineering, or NSE, or sometimes in short it's called nanotech, right? And the definition is written down here, right? It's a way, a study to understand and control of matter, right, in the dimensions of 1 to 100 nanometer. Not just because the dimension is small, but it has to have unique phenomena or properties that enables a new applications, right? That cannot be done by conventional materials. And this nanotechnology involving imaging, measurement, and even theoretical modeling, or manipulating the metals, right? At this length scale, 1 to 100 nanometer. And some examples are given here, including rolls, characterize, manipulate some of the materials called nanotubes, nanowires, or nanoparticles, or sometimes we call quantum dots. Or you are using some of these materials to fabricate devices, right? And as well as working on the theory to understand some of these nanomaterials. Is that okay so far with you? The definition? I believe that you are expert. You know this for a long, long time, right? Okay, the speculation started in US in around year 2000 when they reached the critical mass to talk about this, right? Under the so-called National Nanotechnology Initiative. You can go to this website to find out more. Alright, the speculation will be in another 7 years, alright? Half of the new products in the advanced industrial area, right, including materials, electronics, etc., will involve nanotechnology. Okay? Now say if you go to a shopping mall, you see a lot of the products named under nano already. Okay? So hopefully these are correct. And another speculation will be $1 trillion US world market of products. Okay? You have the key component based on nanotechnology and 2 million new jobs worldwide. And these are the research and development investment from federal agency in this area. Okay. Now it sounds skeptical. It's always true because when people talking big about something new, you say, "Can I believe this?" Right? It's always true because I give you some example here. In 1990s, right? In the 19th century, 25% of people are employed in agriculture, which means one of the 4 person you met must be a farmer, right? And now today we have less than 1%. So at that time, if you tell the farmers, you say, 100 years later, out of 100%, can't even find 1% is a farmer. Do you think they will believe you? So this is skeptical, right? At that time, so we don't know what about nanotechnology. Another speculation. So about 100 years ago, most people will be having an average lifespan of 47 years old. And if you tell them that 100 years later you're going to live until 70 years old, do you think he will believe you? But it happened now there, right? And as a try, you can read on. Heavier than air flying machine are impossible, right? Now you can fly by air anywhere you want. Okay, IBM computer. They said there is a world market of maybe 5 computers. How many computers you have in your lab alone? Maybe more than 5. Okay. There's a lot of examples if you want to go on. Okay. But just to tell you that a lot of promises that we make in the area of nanotechnology still sound very skeptical. So if you work hard, it might come true. Okay. So we don't know. So in order to give you better feeling of what is nanotechnology, I'm going to take these materials called carbon nanotubes. Right? It's one of the examples of nanomaterials to explain to you some of the perspectives or promises about nanotechnology. And now you are ready to play game with the card that you have in your hand, right? Okay, just before we get started, carbon, right? A lot of ladies like diamond. Men also like diamonds, right? So you know diamonds are made of carbon. But it looks very different compared to graphite, which is also made by carbon, right? Graphite is what is inside your pencil lead, right? So what makes them different? You can see that the carbon atoms here are bonded to 1, 2, 3, 4 neighborhoods in the tetragonal geometry. Whereas for graphite, each carbon atom here is bonded to 1, 2, 3. So it forms a triangular structure, and it forms a layer structure, right? So you can see that by changing the way the carbon bond together, you can change the materials with very different properties. So if I give you a whole bunch of carbon atoms, you might be making diamond, or you might be making pencil lead, right? So this is a challenge. Nanotechnology, one way is how will you be able to manipulate atoms into the way that you want, so that you can create a new properties. I'll give you 100 pieces of carbon to 2 groups of people. They might make different materials because there are whole lots of different materials down here, and one of them is called the carbon nanotube, right? So you can see later, diamond is insulated, having a band gap of 5.6 electron volt, right? Graphite, 5.2 electron volt. Graphite is so-called semi-metallic, is conducting and conduct electrons. So they're very different, right? So what about carbon nanotubes? And what you have in the transparency sheet that you have is the so-called graphene sheet, right? Basically, it's a hexagonal network of carbon. So at the corner of each hexagonal corners, you imagine you have some atoms or carbons, okay? And if you roll this in different directions, you will form different materials, okay? You're going to play the game later. Just to tell you that the smallest diameter of nanotubes, which is something like this, can be 0.4 nanometer, right? Just a few atomic, the length of a few carbon atoms, right? And basically, we can roll this graphene sheet to a similar cylinder, then we form the nanotubes, which I'm going to show you later. It can be metallic, right? Like graphite. It can be semiconductor, like silicon, and it can be superconductors as well.